Okay, to remind you what the mean value theorem is, it says if I've got a continuous and differentiable function on a closed interval, on the interval that I just made is a to b, it says that the average slope, okay, that there's going to be an average slope of my function. And then what the mean value theorem says is it guarantees that if my function is continuous and differentiable, there's another point on my blue function that has the same slope as the average slope of my function, meaning the derivative of the tangent line will be the same as the average slope. And how we can write this in a formula is saying that the derivative of my function at c, some point c on my interval, will be equal to the average value, the average slope of my function, which we could use good old change in y over change in x to find the average slope. So again, this is the mean value theorem. It's saying that there will be a point on my function, a point at c, that has the same slope, the derivative, as the average rate of change of my function. So 91 says let f be a function that is differentiable, and they gave us 2 points, 2, -5, and 5, 5. And it said, oh, and 9, -5. 9, -5 is going to be somewhere over here. And it says, which of the following must be true? Does my function have to have at least 2 zeros? If I drew the most basic function to connect those 3 points that we know are involved in my function, do we have to have at least 2 zeros? I would say yes. Could we have more than 2 zeros? Absolutely. But I would say yes, we definitely have to have at least 2 zeros. Do we have to have a horizontal tangent? Well, if we drew my graph like I did, that would mean that we have a horizontal tangent. But couldn't my graph have a cusp or a corner there where that is not differentiable and therefore not having a horizontal tangent line? So I do not like 2. And what 3 is saying, so I like 1, is for some c value, c is going to be between 2 and 5. 2 is here, 5 is here. C is referring to an x value. For some x value between 2 and 5, does the value of my function have to be 3? Well, when x was 2, my y was -5. And when x was 5, my y was 5. And the intermediate value theorem says if my function is continuous, they didn't say continuous, but if a function is differentiable, it has to be continuous. So it's implied. So if my function is continuous, then the intermediate value theorem says that every y value from -5 to 5 is going to be passed at some point. And because 3 is between -5 and 5, I like option 3. Therefore, my answer would be D. And I'm seeing that the answer key is a little out of order from the file that I gave you. So this video is in the same order as your file. Okay, so for 81, it says we're given that we have a continuous function. The intermediate value theorem then guarantees what? So again, I love to draw myself a picture. We got -3, -1. We've got 6, 3. That's all we know about my function. The intermediate value theorem will guarantee that every value, every y coordinate from -1 to 3 is going to have to be crossed. Okay, every y value is going to have to be accounted for on the interval from -3 to 6. Okay, so does that mean that my function has to have the point 0, 0? Well, I slightly drew a misleading picture because my function does not have to look like this. My function could look something, my function could look something like this. Okay, just because when x is 0 does not mean that my y has to be 0. Does my y have to be 0 at some point? Yes, because to go from -1 to 3, I have to cross through 0, but not necessarily at 0. Does my slope have to equal 4/9 between -3 and 6? And this is a little misleading because if I were to do the slope between these 2 points, y minus y over x minus x, I would get 4/9. But the question is asking what is the intermediate value theorem guarantees? The mean value theorem is what B just talked about. So yes, B is true, but it's not answering this question. It's saying on my x interval, for my y's between -1 and 3, my y's have to stay between -1 and 3 on my x interval. I disagree. My y's get to do whatever they please. My y's do not have to be bounded between -1 and 3. So I do not like C. D says that my y has to be 1 once, somewhere between -3 and 6. Is my y value going to have to be 1 somewhere along here? Yes, I do like D. Let's go look at what E is asking though. So E is saying that my y value has to be 0. Yes, I agree with that at some point, but they changed my bounds to be from -1 to 3. My y value does not have to be 0 on these bounds. My y value is going to be 0 anywhere from -3 to 6. So my answer is D. Okay, on 26, I'm going to go ahead and, again, I love a picture. I'm going to go plot what they told me. We've got the point 0, 1, and we've got the point 2, 2, and then we've got the point 1, I'm not sure. And it says the function f is continuous, has values given in the table. The equation y equals a half, or f of x equals a half. That would look like this. That's the line y equals a half. I could just draw it in for you. Y equals a half must have at least 2 solutions, meaning it must get touched twice between 0 and 2. So on this interval, we've got to cross through y equals 1/2 at least twice. And that's going to happen if k is what? Well, if k, let's go ahead and start with B. If k is a half, so that would mean that we have the point 1, 1/2. That would be located right here. And if I were to connect my points, then this line would only be really touched once. And they wanted it at least twice. So I disagree with B. C says, what if my y is, or my k is 1? So my function would have the point 1, 1. And that would be right here. Well, if I connected my 3 points, did I cross my y equals 1/2 at all? Nope. So I don't like 1. D is if x was 2. I'm sorry, not if x is 2. If my k was 2. So if my x was 1, my k is 2, that point is up here. Again, we're not going to cross my k equals a half. If k is 3, we're in the same boat. We're just getting higher. So let's go back to A now. If we have the point 1, 0, that would be down here. And to connect my 3 points, bam to bam, I go through my y equals 1/2 twice. Could it be more? Sure. We have no idea, what else is going to happen, but we're guaranteed at least twice. Answer's A. Okay, we've got a function, root 2x minus 4. Let C be the number that satisfies the mean value theorem for G on the interval from 2 to 10. Well, let me remind you, the mean value theorem is f prime of C equals the average value of my function. I'm sorry, not the average value, the average rate of change. So we'd have f of 10 minus f of 2 all over 10 minus 2. And they're saying there's going to be some other x value that also has this slope. Well, let's go ahead and find f of 10. And actually, I shouldn't have said f of 10. In this case, we're dealing with g's. So g prime at C will be g of 10 minus g of 2 all over 8. All right, g of 10. So if I go ahead and plug in 10 here, I'm going to have g of 10 would be 20 minus 4, which is 16. Square root of 16 is 4. G of 2 is going to be the square root of 0, which is 0, over 8. So we're left with my slope is going to be equal to 1/2. But notice 1/2 is an answer because it's not what they're asking for. We're saying the slope has got to be the derivative. Ooh, I didn't mean to erase that. The derivative has to be equal to 1/2. So I now need to go find g prime of x. I need to go find g prime. I know g of x is equivalent to 2x minus 4 to the half. Therefore, the derivative would be 1/2 times 2x minus 4, take 1 away from the exponent, -1/2, times the derivative of the inside, which is 2. When I simplify that, my 2's will cancel with the half, and I'm left with 1 over root 2x minus 4. The negative puts the square root in the denominator. That's my derivative. And this is saying my derivative will equal 1/2 for what c value or for what x value, them both being the same variable. So I'm going to set this equal to 1/2. I'm going to cross multiply, and I'm going to see 2 equals square root of 2x minus 4. I'm going to square both sides, and I'd get 4 equals 2x minus 4. Add my 4 over, and I get 8 equals 2x, and my x is 4, or my c is 4. Answer C. That was a heavily involved question. This question is so silly. The mean value theorem guarantees the existence of a special point. Special point. Okay. On the graph, y equals the absolute value of x between 0 and 4, 2. What are the coordinates of this point? Well, again, that mean value theorem says that the derivative will equal the average rate of change, which is going to be f of b minus f of a all over b minus a. And in this case, my b will be f of 4 minus f of 0. Those are my two x values all over b minus a, which again is going to be 4 minus 0. F of b, f of 4 is going to be 2. F of 0 is 0. 4 minus 0 is 4. So we get my slope has to be 1/2. My f prime of c, my slope is going to be 1/2. At what x value is what it's asking. What is that special point that has this slope? So what we're going to do is we're going to go find, well, what is the derivative of y? Again, y is x to the 1/2. Therefore, y prime is 1/2 x to the -1/2, which is the same as 1 over 2 root x. And again, when is this derivative equal to my 1/2 for what x value? I'm going to cross multiply, and I'd get 2 equals 2 root x. Divide by 2, and I get 1 equals root x. Square both sides, and I get 1 is my x. My x is 1, so I'm not convinced it's not e yet, but I like my x is 1. Then I would just need to plug in, if my x is 1, what's my y? Well, what's the square root of 1? It's 1, answer B. Finally, the last question says we've got our function. Then there exists a number c. Again, they want that x coordinate on this interval, a to b, that satisfies the conclusion of the mean value theorem. So again, we're looking for f prime of c to equal f of b minus f of a all over b minus a. And we're looking for our c. So f of b would be f of 3 pi over 2 minus f of a, which is pi over 2, all over 3 pi over 2 minus pi over 2. When I plug in 3 pi over 2 into my function, that'd be the sine of 3 pi over 2 over 2 minus the sine at 1 pi over 2 over 2, all over 3 halves pi minus 1 halves pi would be 2 halves pi, which is pi. The sine of 3 pi over 2 divided by 2 is the same as the sine of 3 pi over 2 times 1/2, which would get me 3 pi over 4. Pi over 2 divided by 2 is the same as pi over 2 times 1/2, which would get me pi over 4. And think about your unit circle. The sine at 3/4 of a pi is root 2 over 2. The sine at 1/4 of a pi is also root 2 over 2. Root 2 over 2 minus root 2 over 2 over pi will get me 0. That is what my slope is going to be. And they're saying, well, for what x value is the derivative having that slope? So I've got to go find the derivative of my function. My function, one more time, was the sine of 1/2 x. Therefore, the derivative of sine of 1/2 x would be cosine of 1/2 x times the derivative of 1/2 x, which is 1/2. Therefore, where is this derivative? I don't know why I'm writing that again. Where is this derivative equal to 0? At what x value is this derivative equal to 0? Well, I could divide out my 1/2, and I know that the cosine of 1/2 of x equals 0 over a half, which is still 0. And my question is, when is the cosine 0? The cosine is 0 when my x is what value? Well, I know on the unit circle the cosine is 0. The cosine is 0 when my angle is pi over 2. So when does 1/2 x equal pi over 2? Or when does x over 2 equal pi over 2? That's going to happen when my x is pi. Wow. Answer is D.